Hello and welcome to Quadratics 4.3, solving quadratic equations. Okay, so today we're gonna use complete the square to help us solve quadratics. And hopefully complete the square is still a process that's fresh in your head because I think that was last night's or yesterday's lesson rather. Yeah, depending on when you did it, I guess. Okay, so this first problem is gonna show you how to solve for the quadratic after complete the square has already done its job. Okay, because remember I told you guys last lesson that complete the square, his job, his mission, his power is to turn standard form into vertex form. So what we're looking at right now is vertex form. Okay, so from here, I'm going to show you guys how you can solve for x. Okay, and it's a process that you guys have seen before as far as solving for x. So when you see it, you're just going to be like, oh, okay, I got it. It's not that bad. Okay, so let me just write down the problem right here on the side so that I can just manipulate it as much as I need. Okay, so so far we have to get rid of, in this problem, we have to get rid of three things. Yeah, the negative 5 we got to get rid of, the square, and the negative 36. Okay, so what I like to tell my students is when I get rid of things that are attached to my x, I want to do kind of like reverse PEMDAS, reverse order of operations. So if you were doing regular order of operations, we would deal with the square first, then the parentheses second, then the negative 36 last. Okay, but since we're going to be doing solving for x, I like to tell my students, yeah, let's do the solving of x in reverse PEMDAS order. So whatever normally happens last, we're going to deal with first. Okay, and whatever we deal with first is going to happen last. Okay, so yeah, let's do it. All right, so what do we got? Get rid of the negative 36. Yeah, so how do I get rid of negative 36 and send him to the other side? Well, add 36 on both sides. Okay, and usually, like I said, order of operations says that's usually the last thing to do, to add subtracts. But if I'm solving for x, I'm going to do it first. Okay, so I get left side x minus 5 quantities squared, forgot to write the parentheses, equals 36. Okay, so then we're going to get rid of the exponent because that's usually what happens second in order of operations. Parentheses is first, exponent is second. So we're going to go reverse orders. We're going to deal with the exponent next. Okay, and to get rid of this square, we're going to use what is called a square root. Okay, and I left this space here on purpose because whenever you do square roots on both sides when you solve for x, you need to put a plus minus there. Okay, so keep that in mind. Yeah, when you're solving for your variable, and as part of your process, you do square roots on both sides. Okay, you got to make sure you put a plus minus right next to this square root right here because whatever answer we eventually get is going to be the plus and minus version of him. Okay, so all right, so let's see. Left side, when I take the square root of x minus 5 quantity squared, I get x minus 5. Oops, wrong color. I thought I pushed blue. Maybe I didn't. Okay, let's push blue. Okay, we get x minus 5. Ooh, that's eraser. Okay, x minus 5. There we go. Now I got it back on track. Equals, and then we're going to go plus minus square root of, and then hopefully you recognize 36 as being a perfect square. But if you don't, you can just break up 36 into smaller pieces so that if I notice that they match, I can circle them and I can bring them out of the square root symbol. So I know that 36 is known as 6 times 6, and they'll match. So since they match, I'm going to circle the 6's, which means they're going to jump outside of the square root symbol. Okay, so I still got x minus 5. I'm not going to do anything to that just yet because I have to simplify this square root first. So plus or minus. The 6's got circles, so they're going to jump outside. They're just going to become plus or minus 6. Okay, so for my last step, I'm going to get rid of the negative 5. So I'm going to add 5 on both sides. And I get x all by itself on the left, which is my goal. Then I have equals 5 plus or minus 6. Okay, so here's what you got to remember, yeah. You can't leave your answer like this because a lot of students, they like to leave their answer like this because they think they're all done, right? They got the x by itself, so they think they're all done. But you got to remember, okay, these two things that are left, yeah, 6 and 5, they're like terms. They're regular numbers. You can combine them. Only thing you got to remember is this is not just a normal 6. This is a positive 6 and this is a negative 6. So we're going to get two answers. So the first answer is going to be when I do this, x equals 5 plus 6. The second answer is going to be from x equals 5 minus 6. Okay, so on the left side I'm going to get 11, and on the right side I'm going to get negative 1. Okay, so when I write my answer up here, I'm going to get negative 1 comma 11, and put them in numerical order. So smallest on the left, biggest on the right. Okay, so this was the process that I showed you for how to solve for x when complete the square has already done its job. Okay, so in the next two problems, I think complete the square will not have done its job yet. So the next two problems, we're going to have to actually do two separate process. Yeah, first process is going to be to complete the square, so I get vertex form. Then part 2 of that exact same problem, we're going to do reverse PEMDAS to get x solved for. Okay, so it's going to be a two-part attack in that sense. Okay, first part is complete the square to get vertex form. Second part is do reverse PEMDAS to solve for x. Okay, so you just got to remember the mission of each part of the problem, and if you can do that, then you'll be fine. Okay, so we're going to do a two-part attack for this problem. Okay, so let's write the problem. Hopefully I can squeeze it into this smaller space. If not, I'll just expand the page. But I don't really like to do that because then it makes everything smaller. So we'll see if I can squeeze it in. Okay, so from last night we did complete the square, or maybe not last night, depending on when you guys watched the video. Okay, we're going to grab that middle number, 4, and we're going to cut it in half. And then we're going to square it. And this determines what number should be standing right next to the positive 4x. And in this particular case, the negative 12 is not the number that should be standing next to the 4x. It should be a 4. So we have to politely tell negative 12 to go on the other side. Okay? So we're going to add 12 on both sides. And we get left side is x squared plus 4x equals 12. So leave a little space between the 4x and the equal sign because that's where my number that's going to stand right next to the 4x, that's where he's going to go. Okay, so leave a little space there. So now there's an opening for the 4 to stand right next to the 4x and do what is called complete the square. So I'm going to make that happen. And don't forget, the rules of algebra or math say whatever you add on the left, you have to add the exact same thing on the right. And if you don't do that, you don't remember that rule, then your problem is going to be very, very wrong. Okay? All right, so now we're going to factor this left side, right? So remember the factoring, right? I always taught you guys to start off with 2 parentheses, yeah, for factoring, and the letters in the front are in charge of making x squared in the front. The 2 numbers in the back are going to be in charge of making 4 when I multiply and 4 when I add. Okay, and the beauty of this particular technique is because we're doing complete the square, if you do this technique correctly, you're going to get the exact same parentheses twice. So knowing that, I'm just going to recognize that 4 is a perfect square, and I'm going to say, okay, to get the exact same parentheses, I have to use the same number, so 2 and 2. Then I have a choice. Do I put negative 2, or do I put positive 2, positive 2? Well, I'm trying to get a positive 4 when I add, so I better put positive 2, positive 2. Okay? And then on the right side, I get 16, because I'm going to just add 12 and 4. Okay, so let's clean this up, and I'm going to get x plus 2 quantity squared equals 16. Okay, so remember I told you that the purpose of complete the square is to get vertex form? Okay, and the next step that I do, you're going to be like, well, why are you doing that step? Because in your very next step after that, you're going to kind of like reverse what you just did. So, but I kind of want to keep consistency here, so that whenever you think of complete the square, you know that vertex form is going to appear on your paper. Okay, so is this vertex form right now? No, because this 16, yeah, remember from the other day, the lesson? This 16 is going to have to be turning into my k value. And right now, the k value is not supposed to be on the other side of the equal sign. So how do I move that 16 so he can join the x plus 2 squared? And hopefully you say, well, I'm going to subtract 16. And if you subtract 16, then that eventually turns into your k value. All right, so I'm going to get x plus 2 quantity squared minus 16 equals 0. Okay, so this is what you would call vertex form, right? This is what complete the square's mission is, right? His mission was to get vertex form. So now this looks exactly like we had like the exact same starting point that we had in the very first problem that I did a couple minutes ago. Yeah. So remember I told you guys before I started this problem, we're going to attack this problem with two different things in mind. Part one of my attack is going to get my problem to turn into vertex form. Part two of my attack is going to be to do reverse PEMDAS so I can solve for x. Yeah, so if we can keep these two parts separated, yeah, then you're not going to get confused because you're going to know the mission of part one is to get vertex form on your paper, and once you get vertex form on your paper, you can start part two's mission, which is reverse PEMDAS to solve for x. Okay, so I'm going to write the vertex form right up here on the top. So x plus 2 quantity squared minus 16 equals 0. Okay, so now we're going to start reverse PEMDAS's process, and we're going to solve for x. So here's where you're going to hate me. Yeah, because you're going to be, okay, so you taught us to do reverse PEMDAS, so we're not going to do the plus 2 in the parentheses because that's going to be one of the last things we touch. We're not going to do the exponent because that's going to be the second to the last thing we touch. So we're going to deal with this negative 16. So how do I deal with this negative 16 and set it on the other side? Well, I'm going to add 16. And then here's where you're going to throw your arms up in the air and say, oh my goodness, Ishiko, you just made us do all this work for nothing. Yeah? And yes and no, it is kind of for nothing, but like I said, right, if I teach you complete the square, and sometimes you end here, where it's x plus 2 quantity squared equals 16, and sometimes you end here at vertex form, won't that get confusing as far as when to stop here versus when to stop here? Right? You have two different ending points for complete the square, and you'll get confused. I promise you that, because my students, when I didn't used to teach it this way, used to always get confused as far as when to stop the complete the square process. Yeah? And they would get all crazy and be like, I don't know, I'm so confused, I don't know what to do. Yeah, so I just said, you know what, let's just make it consistent, and let's just stop all the time when I get to vertex form. And that kind of consistency made it less confusing because, yeah, they knew if they didn't get vertex form on their paper, they're not supposed to stop yet. Okay, so let's just do it this way. Trust me, it's better in the long run. Yeah. So what do we have? We have x plus 2 quantity squared equals 16. I leave a little space because when I eventually solve for x, I'm going to have to do square roots on both sides, and I'm going to have to put a plus minus in that blank, so leave a little space. Okay, so now we're going to get rid of the square, so I'm going to square root both sides. And remember I taught you guys in the previous problem, whenever you do square root both sides, you got to put plus or minus. Okay, and if you don't put plus or minus, you're going to miss one answer, and if you miss one answer, you're going to lose like half your points, so don't do that. Okay, so left side I get x plus 2. Right side I get plus or minus, and then I'm going to factor tree that 16, or actually I'm going to recognize that 16 is a perfect square, which is known as 4 times 4. So I'm going to write it as 4 times 4, which means he's going to be circled because they match, and anything that matches inside of a square root is allowed to go outside the square root symbol. So the 4's match, they got circled, they're going to go outside. Okay, so I got x plus 2 on the left equals plus or minus 4 on the right side. Okay, so now to get that x by itself, I'm going to subtract 2 on both sides, and I'm going to get x equals negative 2 plus or minus 4. Okay, so we can't leave our answer like this because negative 2 and the 4, they're like terms, so I have to get them into two separate number answers. So I'm going to, on the left side, go and write negative 2 plus 4. On the right side, I'm going to write x equals negative 2 minus 4. So my first answer is 2 on the left side. My second answer is negative 6 on the right side. Okay. So on my line here, I'm going to write my two answers in numerical order. Smallest on the left, negative 6, comma 2 on the right. Biggest on the right. Okay, and there you go. This problem is done. So let's just go over this again. Left side was complete the square, so I can get vertex form. Right side was reverse PEMDAS, and you're going to be like, oh, I can't find reverse PEMDAS in the packet. Yeah, I know, I made it up. Okay, well, at least I think I made it up. I don't know if that's actually a term in a math book, but I made it up. Yeah, for the purposes of this section. So we're going to do reverse PEMDAS to get the x solved for. Okay? All right, last problem. And same thing, same deal. We're going to do complete the square to get vertex form in part 1 of our attack. And in part 2, we're going to do reverse PEMDAS. Okay, so let's write my original problem. So x squared minus 14x plus 9 equals 0. Okay, so I'm going to grab that negative 14, I'm going to cut it in half, right? Grab the middle number, always cut it in half. I get negative 7. Then I'm going to square negative 7 and I'm going to get 49. So this 49 is a number that should be standing right next to negative 14, but right now 9 is standing next to negative 14. So that's an issue. That's a problem. So we got to tell positive 9 to beat it, right? Just tell them nicely. I mean, don't be mean. Yeah, nobody wants to be told to beat it in a cruel way. So just be nice about it. Okay. So we're going to get 9 out of the picture. So we have x squared minus 14x equals negative 9. And make sure you leave that blank, because we have to leave a blank for 49 to stand next to negative 14. Otherwise, they won't have any room to stand next to the negative 14, and that's kind of important, yeah, to be right next to them so I can complete the square. Okay, so I'm going to add that number that's going to complete negative 14 square. And I can't just add it on the left. I cannot break any math laws, any math rules. I got to add it on both sides. That's kind of important. Don't forget about that. Okay. All right, then I'm going to factor this left side. So I write 2 blank parentheses, and the things in the front are going to be x's because they're in charge of making x squared. And what I put in the back is in charge of making 49 when I multiply and negative 14 when I add. Okay, and remember I told you a couple of times at least that the beauty of this technique is I need to create the exact same parentheses twice. So I know that I'm going to put the exact same number in this blank spot, so 7 and 7, because that's 49, right? That's why we call it complete the square. We're using a perfect square number to make it all happen. And 49 is our perfect square. He's the result of 7 times 7, so I put 7 in that blank. Okay, but now I have a choice to make. I have to either put positive 7, or negative 7, negative 7. Okay, but since I want to add to make a negative 14, yeah, right, I got to add, these numbers need to add to make the middle, negative 14, then they have to be negative 7, negative 7. If I put positive 7, that would add to positive 14, and I don't want that. Okay, so I got to put negative 7. Okay, so the right hand side is going to be 40. Okay, then I'm going to clean this up. I'm going to consolidate x minus 7 that's written twice. I'm going to make it written only once instead, equals 40. And like I said, right, this is where you guys are going to hate me, but it leads to less confusion later, so just follow my advice, people. Okay? When completed square does his job, he makes vertex form appear on your paper. And right now, we're not at vertex form. Okay? To get vertex form, we have to move that 40 to the left side. So we're going to subtract 40 on both sides. And when I subtract 40 on both sides, I get x minus 7 quantity squared minus 40 equals 0. So that's my vertex form. So because I have vertex form on my paper, is complete the square part 1 officially done. Yeah, because like I said, right, when complete the square does his job, he gets vertex form on your paper. And that's what I have. I have vertex form on my, well, it's not really a paper, but my computer, yeah. It's on my, I wrote it down. Okay, so now I can officially start part 2, which is known as reverse PEMDAS, and his objective, his job in life is to solve for x. So let me just rewrite the vertex form at the very, very top on the right-hand side for part 2 to start. So I get x minus 7 squared minus 40 equals 0. Okay, so I got to get rid of negative 7. I got to get rid of the square. I got to get rid of negative 40. So reverse PEMDAS tells me to get rid of negative 40 first, because usually in order of operations, negative 40 happens last. But in reverse PEMDAS, or reverse order of operations, if you want to call it that also, negative 40 is going to be the first to go. So I'm going to add 40 both sides. Okay, so left side I get, I hope this is blue. Okay, I hit the right button. X minus 7 quantity squared equals, and leave a space, 40. Okay, so next I want to get rid of the square, so I got a square root. And remember the rule, whenever you square root both sides, you put a plus minus right in that blank spot that I left right there. Okay, so left side is x minus 7. And right side is not a perfect square like the previous 2 problems. It's 40. Okay, so here's where you're going to be like, whoa, how'd you do that? Well, it's called practice, people. Okay, and you're going to be like, what did I do? I didn't show it to you yet. Well, I'm going to factor tree this thing called 40 in my head. Okay, so I know 40 is made up of 5 times 8. And I know 8 is known as 3 2's, so 2 times 2 times 2, and then the 5, right? So 2 times 2 times 2 is 8, times 5 is 40. So eventually when you start practicing this enough, you'll be able to factor tree things in your head real fast and just write it down in the square root symbol just like I did. Okay, but you got to be honest with yourself. Remember I told you guys in the beginning of these videos that in my class in particular, you're not allowed to use a calculator until the 4th quarter. Okay, because I need to make your brain strong. Because I can't expect your brain to do this kind of stuff in your head if you've been using a calculator all year long so far. So I need you to be honest with yourself, and I need you to stop using the calculator. Otherwise, when I start doing this in videos, you're going to be like, whoa, what just happened? You're going to get lost. And then because you get lost at that one particular part, whatever I say after that, you're not going to hear because you're still trying to figure out how I did this part right here. Okay, so 40 is known as 8 times 5. 8 is known as 2 times 2 times 2. So these 3 2's are your 8 times the 5 is 40. Okay, and I'm going to circle things that match, and all that matches are a pair of 2's. So this is the only thing that's going to get to go outside. All right, so I get x minus 7 on the left side equals plus or minus 2 root. And then if I can't circle the 2 and the 5, I just put them back together again like Humpty Dumpty, and I get a 10. Okay, I'm almost done. I just got to get rid of that 7. So I just add 7 on both sides. And I get x equals 7 plus or minus 2 root 10. Okay, and you can leave your answer like that because these guys are not like terms. Okay, if this 7 had a square root 10 attached to the back end of it, then we would have like terms, but it does not. Okay, so I know, yes, all you see are numbers, you don't see any letters at all, but you can treat radical 10 or square root 10 as if it was a variable. So because 7 doesn't have a square root 10 on the back end of it, you cannot combine the 7 and the 2 together. Okay, if I turn these into decimals, yeah, I guess you could, but I'm not going to do that. I'm not going to make you guys do that, especially if I'm not going to give you a calculator. Okay, so you just leave your answer like this, 7 plus or minus 2 square root 10, and we're done. Okay, so that was the last problem. Good luck on your homework, and I'll see you in class. Bye-bye.